Hello and welcome back. And I am joined by Roy, who is going to be the next speaker for the day. So, Roy, how are you?
Good. How are you?
I'm good, thank you. So, this is your second time at Umbraco Community
Yes.
Day. So, you've been
Yeah.
a part of the first one from the studio, and I think you co hosted with me for a little bit as well. The first
No,
edition,
I
we had
didn't.
a little bit of
Yeah,
chat, I
we had a
think.
talk.
Yeah,
Yes.
yeah.
Yeah.
And so, um, why don't you introduce yourself and then you can take the stage whenever you want.
Yes. So I'm a Roy. I'm a software engineer at IO, mainly working on medium to large clients with Umbraco and a lot of modern stuff. That's what I'm going to be talking about today.
Sure, absolutely. So the stage is all yours.
Yes.
I'll leave you to the talk. Thank you
Thank
very
you.
much.
So welcome. Nice to meet you. And I just did the introduction already. But I'm working mainly with Umbraco, Mag and .NET, and that is what I'm going to be talking about today. But first, I have a question. Can you work agile when your technology isn't? Because a lot of us claim we're agile when we're doing all these processes, but then when it comes down to the technology, we might not be. If you look at last year, a lot of new technologies came out. For example, we have the AI trend, and a lot of clients wanted to have, for example, AI in their search engine. It was a very big request. Make everything smart, make everything a chatbot. But then it's harder than you might think it is. So that's why we're building a strong foundation for your modern .NET project. I'll be breaking it down into three categories. So the first one is architecture, which is pretty high over. Then we're diving a bit down into a little bit more software design. And then at last, we'll have some code. So a strong foundation. So how do we define a foundation? The foundation is a pretty abstract term, of course, because we're mainly talking about a strong architecture. But what do we look at? Do we look at stability, scalability, ease of maintenance, things like that? Well, I think we can break it down because we actually define a foundation with our clients. And there are basically two things that we need to write down, which are functional requirements and then non-functional requirements. Functional requirements is something that we all know, and usually we write these down in user stories. So as a logged in user, I want to place an item in my cart so I can order it, etc. These are all known to us. But then on the other side of that are the non-functional requirements, which more talk about the operation rather than the behavior. So it's non-functional. And an example of this is probably number of requests per second, or maybe uptime of a module, downtime after deployment, a lot of things like that. And these non-functional requirements are very important to talk about with the client, because if there's no expectation, then we probably won't set any, or we might do more than is needed. We have a lot of categories in this, probably tens, but I wrote down the most important ones. So usually we talk about performance, security, availability, usability, scalability, reliability, and maintainability. Those are a lot of abilities. So now I want to talk a bit about future-proof architecture. With future-proof architecture, we want to have freedom of choice, we want to be flexible, and we want to be adaptable. What does that look like? First of all, with future-proof architecture, we want to choose the best of class over a best of breed. And the best of breed is usually the very best product in the ecosystem in its class. And best of class is usually choosing the right fit. So it's a little bit smaller, and we're not using the very best. We're just choosing what is right for us. Just to clear this up a bit more, that best of breed is usually referred to as enterprise software. These big pieces of software that do everything for you, from content management to marketing to whatever. But a lot of times these are very closed off. So within the ecosystem, we can use the identity, we can use personalization, but when we want to reuse it, there's a problem. So that is usually a problem with best of breed. It doesn't have to be wrong if you're fully using everything, but a lot of time the client is paying for something they're not using. So with best of class, we're focusing on a single category, like for example, identity, and then we're choosing the product that fits best. Like we have Azure AD, we have Okta, we have Auth0, stuff like that. We're looking further than our breed. Of course, best of class is also for reusability. So when we write identity once, we might want to reuse in different projects for the same client. And that's when we're composing to the business needs. So we start small and we try before we buy, which usually means a proof of concept. So you don't have to invest in something directly. We can just try it out, move to the next one. Because we're doing it more composable, we can just replace components when they don't succeed. Because sometimes we might have something in production for 6 months and then we're not really happy with it. We can't achieve what we want or it's too expensive. Then we shouldn't be afraid to replace components. With future-proof architecture, we're also talking about flexibility. So of course, flexibility stimulates innovation because we can do new things on the way. We're not stuck to something big. We can just try out things when they come out. And yeah, this is also when the business demands it. For example, the AI example I did before. A lot of search engines with AI are there. Now we want to use them. We should be flexible on that. And with adaptability, we talk about also adopting new technologies, but it doesn't have to be a new software suite. It can also be within the same component. So, for example, a big version of Umbraco comes out. We need to adopt to a newer version. So, future-proof architecture is composing to your needs. It's keeping your options open, and you should also, well, it's a strong foundation. So, it's basically a composable solution. And I think that's the composable DXP story. There it is. When we're composing, we're decoupling the application. So we're separating everything into our own modules, and that's what this AI art is also showing. But we're keeping everything loosely coupled. Basically what we talked about in the previous section. And but we can also compose for our own. It doesn't have to be all software as a service packets. We can also create our own components. We can use the best of everything. So maybe something isn't fitting, you can create it ourselves. And we usually write middleware to communicate between these components. And when we're writing our own software, it's very often done with the MAG way. So microservice, API first, cloud native, and headless. And we probably all heard of this before. But I want to dive into each subject a little bit and just show how it relates to the future-proof architecture. So the components should have a single responsibility. And of course, they will be flexible in development. Because we can develop one thing, leave the other one be. And then we can innovate on each component, so on each microservice, without exposing the whole system. We're working API first because that is the contract between the modules. So when everything is loosely coupled, we want to have one contract. For an example of this would probably be OAuth. Well, every identity provider uses this. That is the contract. We can just swap it out without other components needing to change. Maybe they need to change, but it's not resource intensive. Of course, that also allows for the adaptability we talked about earlier. So with a single contract, and we can just do new things. We're building cloud native, and we're designing for the cloud now, because we can scale when needed, and we can also rapidly recover from system failures. This is one that's, of course, a positive when you were working on-premise before. And the last one, headless, which is also a big topic the last few years. It's also more about decoupling presentation from the logic. So our services on the bottom can be SAR, and our content or presentation, can be omni-channel. So we can show the same stuff on multiple devices, or maybe different apps can reuse logic. And we're also technology agnostic, because the front end can be a React app, Angular, Vue. And then it's also optimized for the end user, because we don't have a single front end anymore. We could create multiple front ends for multiple target audiences. So working MAG is also flexible, it's also scalable, and it's resilient. And this is responsive to changing markets. So when our client demands something, we can act on it easier. So it's not free, of course, it's less resource intensive. So one peel down, I want to talk a bit about software design. So thus far we've talked about architecture, and it's all very abstract, modules and magic. But how can we do this? Well, first, what is software architecture versus design? The architecture is the concern of the whole, so we're looking at all the components together. It's like the big puzzle. But then design is more the concern of the individual. So for example, one component, how it's made, and the blueprints for that. So here we see architecture, which is also, this is of course very abstract. But this is basically a web shop with a headless website, 3 services, and they all have their different type of storage. It's a high-level overview of the system, and it only contains, well, external visible properties. So whatever happens inside of catalogers, we don't know. We just know it's returning products. Then when we look inside of it, we're looking at software design. So now we have a product controller, for example, which has a catalogers interface, which has some provider and some sort. And it's the detailed specification. So these are really the blueprints. And I want to look at the software design principles called SOLID, but only the S and the ID, because I think these are most used here when also looking at modules in their whole. So the first one is the single responsibility principle. We've probably all heard it. But what does it do exactly? Well, it's that modules should only have one reason to change. So it's not really about one responsibility. It's more about one domain. So it's of course in one scope of a single subject. Then we're using dependency inversion, which is well, that high-level modules should not depend on low-level. And what that means is that whenever we're working with something, like for example, in example, we have a geocoding interface. The dependency from the controller is on some sort of geocoding interface, which we can use to get coordinates from a real-life address. But then for me, it doesn't matter if that is Mapbox or Google Maps. And by separating this, by inverting the dependency, we can also swap out Mapbox for Google Maps. Thirdly, we have the interface segregation principle. And this one is kind of the first two combined, because now we have a single responsibility for interfaces. And that also means, like you can see in an example, that the address and the destination controller are using different interfaces, but they're both using Mapbox, and they don't know that. The destination of the direction, sorry, is better with Google Maps, for example. So now I want to switch to Google Maps, and Mapbox can coexist in our solution, and we don't have to change anything on the geocoding side. So these things are all about keeping options open. We don't want to depend on something detailed. So we're isolating modules, and we open the pathways for the future. Another part of software architecture and design is probably clean architecture, which I want to go into briefly. So clean architecture is a way of building your, for example, your microservices to make those components resilient. So in short, clean architecture, well, it's a design philosophy, really. We're splitting the system into different layers, and then each layer has its own responsibility. So I'm going to go through the layers briefly, which is the presentation layer. And this is on the outer ring. So this is what's talking with the outside world. And this is also where the contract is made within the application to the outside world. So this supports an API-first approach. Then we have the application layer, which is basically your use cases, your features, everything that binds together the outside world with your entities, your domain logic. And this allows for flexibility. So something can change in presentation, and it doesn't have to change in your core logic. And the core logic itself is, well, the domain layer. So this is the most inner ring. And this is coupling from within use cases. Lastly, we have the infrastructure layer, which is also on the outside, but is opposite the presentation. This is basically the backdoor to your system. This is, well, every external system through the infrastructure. So key principles. When we're decoupling and we're independent of any frameworks, we're independent of any API specifications in our logic, and we're independent of any external services. which makes it that we have a maintainable, testable, and flexible component. So I want to prove it. So here we have we have another drawing, and the outer ring and the inner ring, they have different responsibilities. But the outer ring is whatever is in our component structure. So here we see the bigger component in the middle with these two rings. And when the outside world changes, the inside world changes, so for example, we're adopting new technologies, then the outside is probably untouched because the outside has the contract, and then external services are talking to that contract. So we can go from red to blue, and it doesn't really matter. So clean architecture is really about freedom, flexibility, and adaptability again. So I think this is the circle, and we have future-proof architecture. So lastly, I want to talk a bit about code. So I'm not going to show any code examples, but just things you can do to keep your code organized. Because code is a tool, and the foundation is more than code. But this is the tool to realize it. Because if you have a no code or a low code platform, you also need to have a foundation of some sort. But then code is probably the last step of doing it right. Because code is very difficult to the human mind, of course, and we do all kinds of stuff to develop it. So we should make it readable, maintainable, probably scalable, efficient, testable, all of these things. And how can we do that? Well, we have a code style. And with a code style, we're basically telling to each other as a team, well, we're going to do first a constructor, and we're going to have some methods. Maybe fields should be first, just to make team code as one. And this is probably essential part in software design, because if we don't have a code style, so if we don't talk about it, then every developer working on a project is going to have a different style of working. And after a year, maybe after 2 years, it's going to be unmaintainable. We could make, we should make this code style with the gatekeeper. So applying it is also key. So we could say to each other, well, we're doing this code style, but then after a year, new developers come on the team, and we're not doing it anymore. So we need to have some sort of static code analysis to warn you about offenses. And a popular one is StyleCop, which is a roster analyzer, and it will have a set of predefined rules which you can turn off or you can configure. And then whenever you do something in your code, you will get a warning if you don't comply. And that's nice, because now we see a lot of things like we should make our classes sealed, we should use string empty for empty strings, etc. But then I also think that warnings are errors. Because if we have a lot of warnings and we're not following our code style, and they're basically errors. Because we're not breaking the application itself, but we're really breaking the maintainability. So I shouldn't say that we should literally turn them into errors, because then we can't develop. But when you're done developing, just look behind you, clean it up a bit, make sure you're complying, and then you can merge it back to main, for example. Lastly, which goes a bit further than only code style, is static code analysis. Tools like SonarQube are using their smart analyzers to look at bugs, testability of your code, to look at technical depth. So if a lot of code smells, which is something we're trying to find with code style, are there, then that might mean a lot of depth. And it really makes it measurable. So we could say we have technical depth, but this says it, well, there's 10 days of technical depth here. It sounds like a lot, that's probably a lot. But for some reason, it's still okay with it, because maintainability is still an ape. So yeah, it does a lot of smart things. And that's all. Of course, I went a bit quick, but that's okay, I think. You should contact me if you have any questions. I wrote a small blog post on this with a behind the screens photo and the slides, so you can download them there.
Thank you, Roy. That was wonderful, and I think that was a slide deck full of information.
Yes.
On how developers can take things forward. One thing which particularly caught my eye was towards the end there was warnings equals errors.
Yes.
That's fantastic.
Yeah.
Do you want to just elaborate a bit more on that, maybe?
Yeah, so I could go back to the slide.
Yeah.
A lot of times when we work with, maybe we start working on a project that's already there for a long time, and then we open Visual Studio, and then all the errors start coming in. I think when there's only one error, we can see, right? We might ignore it, but then the more errors there are, or sorry, the more warnings there are, we don't look at it anymore. So maybe 10, 20, and we just stop looking. But that's a lot of important information.
Absolutely. That code actually reveals a lot of information behind the scenes, I guess,
Yes.
isn't it? Yeah.
Yeah.
This is, I think, one of those advices that is always out there, but
Yeah.
given the time constraints that we all have in our projects, this is probably overlooked. And I'm assuming that something like SonarCube is going to pick up on this and flag
Yes.
that up as well for you. That was wonderful and such a nice slide deck. I'm pretty sure that we are going to have people asking you for the slides because, as I said, each of these slides were like really good starting points on what more I can do and build on top
Yeah.
of that knowledge that's been given to me. So are you planning to share your slides at all?
Yes, they're on the website.
Oh,
I
brilliant.
released them, so you can check there.
Absolutely.
Yeah.
Great stuff. And before we wrap up, is there anything else, or should we just continue the conversation?
Yes.
Because we are talking about .NET. And of course, just over a month ago, or just closer to a month, we've had the fantastic .NET 8, which is the greatest and latest .NET 8
Yeah,
.NET
I
version
agree.
so far. Yeah,
Yeah.
absolutely. So, um, of course, there's Umbraco, there's .NET. How do you keep up with the changes? What do you find more interesting? What do you find is really interesting in .NET 8 and probably the versions of .NET that we've been going through?
Yeah, so a lot of things I talked about in this talk are not solved, but are done for you with .NET Aspire, for example.
Oh, of course, of
Yes.
course. Why didn't we talk about .NET 8 and Aspire?
Yes.
Have you given it a try? I haven't
I have.
personally given it a try.
I have.
Oh, brilliant.
Yeah, I'm very excited about the telemetry. So a lot of whenever we run stuff in production, of course you can also do it right now, but it's a lot of hassle to put everything together, make it work in different environments. But for example, with the logging with Aspire, it's really easy. You say, well, add logging, and then it's done. You just need to make sure everything's configured well, but there's not really that much hassle. And then even in production environments where you don't really want to log everything because of maybe personal data, we still have all the information to debug problems.
Yeah, I guess that makes a change to developers' life as
Yeah.
such, because as you said, personal information, we can't log it, but when you need that log to actually make you go to the next step and debug something, this is absolutely valuable. So that's brilliant. That's another tip for everyone to go and have a look at. And that is it from Roy. And I think we have time for a little break, probably 6 minutes or so before we start the next session. So don't go anywhere. We are going to be back soon with more talks, panels, and of course, don't miss out on the Ask Me Anything session with Scott Hanselman. We will be back soon.